Hello and welcome to session 6. In this session we're going to look at secondary DNS servers. In effect, we're going to be taking our DNS server, the singular primary server, adding in the secondaries and actually creating our DNS system, our domain name system in full. We're going to do a little bit of background as to where it comes from, then we're going to look at the setup requirements. And in these setups we're going to have 3 servers. So when we get to the workshop, we're actually going to have to get all those servers created. So there's quite a bit of development work to do to get the final workshop done. So need to bear that in mind. Once we've done that, what we're going to do is we're going to look at how we can manage the DNS once it's in that configuration. And the other bit we're going to do is have a quick look at querying, which is a technique we can use to actually log information and use that information to then tweak the parameters within the DNS architecture just to fine-tune how it works. So what are the secondary servers going to do for us? Well, in effect, they really do 2 major things. One of them is they give us some redundancy. What they do is they provide us with a means by which we can have multiple machines providing the service. So if any of the machines stops functioning, the other can take over. So you'll notice in the DNS settings of most client machines, there's normally multiple domain name servers. Those multiple domain name servers are usually the actual secondary servers that provide the information or the domain name information for that subnet. At the same time as providing us with that redundancy, by using the secondary servers, we can actually move the primary server away from public access or even the local access from the machines. We can start moving it out of the way and protecting it. At the end of the day, the primary server is holding that master database, which is then transferred to the secondaries. So we're making sure that that primary database, by hiding it away, can't be corrupted. The other thing we are now moving towards is when we had the SOA record and we were using the serial number and the negative cache. So we were using the first field, the serial number, and we were using the last field, the actual negative cache, and that was all. The other numbers, the other cycles or second cycles, the timers that we had within there, we weren't using them. The serial number is important because the serial number has to be incremented after every change on the primary. That's a way of indicating to the secondary servers that a change has been made. But that's purely when the actual communications is set up and being activated, which is slightly different. So we've got the serial number, which we're aware of, and we're aware we have to increment it. We have the very final value, which is the negative cache, which means if a name cannot be provided, it says how long we should not go back to the server. But the other 3 values that we have are specifically there to control the secondary DNS's mode of operation. First of all, we have the time interval, which is the first of the second entry in that block that we saw after the serial number. And what that does is that tells the secondary servers how often they should go back to the primary server to bring down any updates to the database. A check-in, in other words. Check-in, are there any changes? If there's no changes, I'm quite happy, just keep going. Otherwise, when I check in, if there's any changes, bring those changes down. The next one, the next in line in that sequence, is the actual time cycle for how long the secondary server can actually be an authoritative server if, when it's been back to check the primary server, it's no longer there. So every time interval, there is a check, and it will check to see if there's any changes on the server, but also to see if the server is actually there. If the server isn't there, the secondary server will now start this secondary clock to say, how long can I keep giving records out? So this is the fault tolerance. However, we have to also bear in mind that there may be an issue with the primary server and things being changed. So sometimes records can go out of sync here if the database is not being transferred to the secondaries. So the secondaries have now a secondary time cycle to say how long they can give out records, the ones they currently have, without the primary server being active and running. And then the last entry is the frequency check. On top of that, if it finds that the primary server isn't there, it has to go back and check. And so the frequency check is that component. So the first part is, how often do I check the primary server? The next one is to say, if I don't find it, how long should I wait, and how long should I continue to give out answers? And the final one is to say, how often should I then go back and check to make sure the primary server is back online? That's quite a bit. Now, the next thing we need to do is, now having that understanding of how the SOA record controls the secondaries, what we need to do is start looking at how we can actually get these secondary servers built in the first place. Well, the first part's straightforward. We install By9 and the DNS utilities because that's how we manage it. The next thing we need to do is we actually need to start adding the zones, or the zones that the secondary servers are actually going to be allowed to distribute. And that's all done in the namedconf local file. Now, don't forget, the options file is still there for forwarders or using route hints. So each individual secondary server can have that component separately configured. But in general, you'll find that they're all configured the same way. So if you want to use route hints, all secondary servers are set up that way. If you want to use forwarders, you set all the secondaries up to use those forwarders. But the next part is actually getting the zones that we are actually going to be authoritative for set up. And that's all done in namedconf local. When we do this, what we have to be sure of is the actual domain name that we're actually going to be the secondary server for has to be declared in exactly the same format as the primary server. So in the primary server, if we are saying we're distributing student.co.uk, in the secondary servers, there will be a zone declaration of student.co.uk, and that's how they know which zone they're actually going to pull down. But that's not all that it's going to have to do. Now also, just like the primary server, secondary servers can have multiple zones that they use. Now, before we can get all of this working, there is a slight issue, and that is, how do the secondary servers know where the primary servers are, and how does the primary server know that these secondary servers that are going to try and grab all these records are actually allowed to have them in the first place? Because if we don't set this part up correctly, we are either going to have secondary servers that don't work, or potentially we're going to be opening up a vulnerability in our domain name service by allowing our DNS server to be enumerated, which we don't want. Enumeration of DNS servers is normally the first part of a reconnaissance exercise that people will try to see what is the layout of the actual network. A simple query can actually grab all of the records to give us a map of where all of the actual hosts are on a network. So we need to get this bit very, very precise. When it comes to allowing the transfer of the zones, in other words, this bit that allows the records or the database that's held on the primary server to be transferred to secondaries, we have to add in the directive allow transfer. What we do in allow transfer is we specify a list or an individual entry of the secondary servers that exist. So in the case of this setup here, I've said allow transfer, and I've specified 2 IP addresses. That means those IP addresses are the secondary servers, and they are the only IP addresses that are allowed to communicate back to this DNS server, the primary server, to say, give me all of your records for, in this case, the student.co.uk zone. So this is actually opening up the ability to transfer all of the database records from the dbstudent.co.uk file over to another machine. That's enumeration if it's done illegally. If it's done in the context of what we're setting up, this is allowing the secondary servers to have the database populated to give out authoritative records. So on the primary server, we use allow transfer to open up the access to the database. On the secondary servers, what we have to do is now we have to declare the type of server as a slave. That's how we say this zone is actually not going to have a database locally that we are going to manage and maintain. It's going to be done for us automatically as a slave. And the file name here we've specified is the same file name as we used in the original machine, but we actually don't need to declare a file. The reason for declaring a file is so that all of the records when they're transferred are stored locally instead of just in memory. That means if we restarted a secondary server, it would automatically load all the records locally rather than having to transfer all the data again. which obviously puts an overhead on the network. And if the database is large, it could potentially have an impact. The last part is how we specify where the actual primary server is for this domain. And in the case of this one, we've said masters is 192.168.101.28. You can have multiple masters, but in this case, we're only specifying one. So in effect, I've created a little network of 3 machines here. We've got a primary that's allowing 2 secondaries, and we've now got a secondary that is calling back. So we now have the bidirectional communications. Now, the idea of that performance of using the file name is, as I say, purely for performance of startup of the secondary servers. Now, that database, when it is transferred and stored temporarily, is actually stored in the var cache bind folder, which you'll have noticed is a declaration that we have in the actual options file. So it brings it down, stores it in that location temporarily. So it's written the file to that location. And we'll come on to the read, write, and some security on file systems in a moment. The other thing we need to do is, if we want to start hiding where the primary server is, we now need to start not broadcasting it through the name server records. Now, the initial primary server, when you set it up, it specifically says in the standards that you must have a name server record. So when we set the primary up, it has a name server record within it. However, now we've got secondaries, we're in a slightly different position. What we can now do is say, okay, these secondaries are the name servers, but the primary is no longer going to be a name server in the infrastructure, or at least we're not going to broadcast its existence. So what we do now is we take the name server records, we add the name server records to that primary database, but the name server records now specify the secondary servers, and we do not include an entry for the primary server at all. Now, if anybody queries the zone and says, give me a list of your name servers, they will only be given a list of secondary servers. So let's have a little scenario here. On that primary DNS, how do we actually set that up? Well, here's a scenario. We've got 3 servers. The primary server is on 55, and we've got 2 secondary servers, one on 56 and one on 57. What we would do is any reference to the 0.55 entry and as a name server would be removed. What we would then do is we would declare the 2 name server records pointing to 2 servers on our network, and their addresses would then be set within their records, so the name server can actually be looked up to get an IP address. So in this case, there's 2 name servers, and the 2 name servers are running on 192.168.0.56 and 57. And there is no reference through name server to 0.55. So we've removed it from the equation. What we can do at this point is we could actually move that name server somewhere, the primary name server, somewhere more secure. In fact, we could probably put it behind a firewall to actually add an even further level of security to the infrastructure. In effect, what we've done is in the zone, we only declare the secondaries. The primary is now free to be moved wherever we want it to go, and any name server queries will not reveal where the primary server is. And the SOA record, what's that now doing in this? Well, the zone has an SOA record, and with that, we're now tailoring the time cycle for updates and checks to where the primary server is, and how to then validate or keep going back to check for that DNS server if there is an issue. So in effect, the SOA record is now controlling those secondary servers. Now, before, one of the things I actually said was when we set the primary server up, there's this notify no option we could use. If we use notify no on a primary server, whenever we reboot it, it will not call out to the secondary servers to say, I've just started, you need to pull some updates. It will just simply start and will not do anything. It will sit idle. It will just load itself up. If that's the case and we've said notify no, the only way we can actually update the secondary servers is by the secondary servers using the SOA record, in this case the refresh, which would be here, using this value, and it would periodically go back to the server to check it. So if we restarted the server and there's no issues, this is the only way that the update check would take place. Now, once we've got this all set up, what we have to do is restart all the servers. When we set it up, what we want to do is reset all of the time cycles, and the best way to do that is to restart the primary and then the two secondaries. What will then happen is when the secondaries are restarted, when a secondary restarts, it will do a check-in, it will pull down and do an update test. So restart the primary server first to make sure everything works okay, restart the two secondary servers, and we're now ready to go, and that is now ready for to actually be pushed out as a production infrastructure. Remember, all of the secondary cache databases are stored in var cache bind. If that file name is specified, that's where they'll go. If the file name isn't specified, it may put records in there temporarily, but the actual database itself will be stored in memory. So this location, this var cache bind, is actually managed by an application called AppArmor. Now on Ubuntu, there is a tool or a utility that runs called AppArmor, and what it does is it just provides us with a security umbrella over all of our applications. Now, we're going to actually have a little look at that, but it's slightly artificial, the reason we're looking at it, because it is possible to configure logging within the system without using any AppArmor changes. But I want to actually add them in so we can see what AppArmor does as a tool, and because it's a security measure and it's something that we should know about. When we've actually got all this infrastructure set up, one of the things that will happen is there will be transactions between the primary and secondary servers. And if we want to have a look at those as they actually move on through their updates, what we can do is we can look at the syslog file. So the system log is where the primary and secondary DNS servers log their actual activity. So if the primary server is restarted, it puts entries in the log file. If the secondary servers do a callback to the primary, that's also in the log files as well. So the syslog file on the primaries and secondaries is a good debug tool to use when we're trying to see what's going on. We've used it in the past in this module where we've used tail command. And for instance here I've said tail -25 and we list the last 25 lines of the log file up. We used it by putting grep in there as well so we could filter out the messages. If we want to actually have our servers running live and we want to monitor the log files in real time, if we use the last command, tail -f var log syslog, we can actually watch entries being put into the syslog in real time. So when an update occurs, we would see it on the screen automatically. So these are just another couple of techniques we can use just to keep an eye on what's going on within the infrastructure. Now sometimes, if notify no is set, we have an issue. And that would be if change needs to be forced through the system. Now, there's a few ways we can do that. One of the things we can do is we could just restart all the servers and that would actually do a flush through for us. But we're not in a position to do it on a live system. So what do? Well, we're dependent on the SOA record, but if the SOA record timing cycle is not going to do what we want and we need an immediate update because we've done some kind of reconfiguration, we can actually use the rndc command. And what the rndc command does is, if we're on a secondary server and we run rndc refresh and then the zone name, it will instigate a zone transfer from the primary server, which is out of band. So this server that we're running is got a time cycle, and that time cycle is not scheduled to say run for another 24 hours, but we want the update now. We would simply say refresh the zone and force that update. Now, if any of you are using ISPs to manage your DNS servers, you may find that they say any updates could take potentially 12 hours. And this is the reason why, because the SOA record is what is controlling the actual updates that the secondary servers make. And what you're doing is you're adding records to the primary server. So if they say on average 12 hours, that means what they've got is they've got a 24-hour cycle on when the refresh is done. So if it's a 24 cycle, you could add it just after the 24 and have to wait 24, or you could have added it just before the 24, in which case it would just take a few seconds to go through. So if it's a 24 cycle update, a 24-hour update cycle, the average would be around about 12 hours. So the rndc command is just an easy way of getting out of that cycle and forcing updates through the system. Which brings me on to logging. And the logging is the interesting part now, because we've got this all set up, we're running it, we're using it, but we want to start tweaking all the parameters. We want to look at how effective the time to lives are, the SOA record doing the propagations. Is it actually working the way we expected it to work? And likewise, when we've got all that running, what are people doing with the DNS servers? What are they using them for? So logging is a practice, putting in logging facilities is a practice whereby we can actually grab the query activity, analyze it, and then make changes to the parameters to get the best out of the DNS architecture. A couple of things you need to bear in mind though. It can also be used as a big brother mechanism. It can be used to find out what your users are doing, because you have a source IP address and where people are actually doing searches for. In other words, the sites they're going to when they're putting in URL names. So that's a bit big brother. The other one it can do is, if we're actually analyzing the network traffic, we can look at potentially where there are being redirected sites, etc. And potentially we can actually say, well, these sites we really don't want people to be going to. They hold malware, for instance, and you're in a position to start blocking those URLs. So there's a lot of use for the DNS activity. One is to tweak and manage the DNS itself to get the parameters right, and the other is to look at the user activity and to control that as well. So how do we set it up? Well, there's two things that we need to be aware of. When we're setting up logging, we have a channel. And a channel is how we define an actual log file and where it's located, etc. And then the other part is we have to say what we actually want to be logging into that file. So that's the category. So a basic setup would be, in the namedconf local file, at the end of the zone declarations, we can say, I just want to switch on logging globally. We can do it on individual zones, but generally speaking, this is something you're doing at the DNS server level to look at what the activity is on the domain name service. So on each of the domain names controllers we have, we would add in a logging facility. We would declare the channel. In this case, I've said the channel is called query.log. It has a file declaration, which is where we want the log file to go. And in this case, notice I'm using var log. Now, because I'm trying to do this, I'm going to have to open up the security on that file for the logging. If I'd put it into var log named, I wouldn't need to do this. It would just work automatically. Severity debug level 3, that means how much information, and there are various debug levels, but that's just the amount of information that's going to go in. And then category dictates that we only want to log the queries that are actually being fired off at this DNS server. We need to create the log file. So what we would need to do is we would need to create that log file in the log area. So var log, we would need to create a file called query.log. The easiest way to do that is running the sudo command with touch, and that just creates an empty file. Now the bind program runs under the username bind. So what we now need to do is change the ownership of that log file. So we use the chown command, which is change owner, and we change the owner of the file from root to bind. That will give us the access to the file that we need. Well, not quite. It gives us the access rights for the user account, but AppArmor is in there now, and AppArmor sees the var log folder as not having any kind of read-write access at all. So we need to open that up now. So as I said, AppArmor is an umbrella application that sits over all the processes and controls access to file systems. The idea behind that is if any service is compromised on the machine, it's not possible for them to start changing files in areas they don't have authority. So we're starting to put in protection measures for our entire box. Now, any box that has got any kind of public access or even remote access to the service whatsoever should have this kind of protection within it. AppArmor is doing this for the bind service. The bind service works on the principle of we have profiles that are declared that actually set up the access rights for the process. So for the named process, which is bind, that file is located, the actual process, the program that is run is located in the file user sbin, and the file is called named. AppArmor has a directory where all the configuration files are, and basically in there all we do is specify, by replacing the slashes in the file name, we specify where that process is that we're going to control. So because named or bind is actually executed from the file user sbin named. Within AppArmor.d, there is a file name created called user sbin named. That file contains the access rights that this program has. So AppArmor loads all of the configurations or profiles from that directory to control each process's access to the main system. Now what we've got to do is we've got to open up that log file to allow our named process to be able to make entries in there. So in that file, what we have to do is make a change. What we need to do is we need to go to the bottom of that file and we need to add in the file name that it's got access to. So this is quite fine grain. Instead of saying, oh, this directory, I'm actually saying a very specific file. So at the bottom, I can say varlog query.log, and I want it to have RW access, which stands for read-write. So it can read the log file and it can write to the log file. So I just add that entry to the end, and that's that made. That is a change to the profile. However, we have a slight issue. AppArmor is protecting more than just the bind service. So what I wouldn't want to do is stop the AppArmor process and then allow the changes to take place by restarting it. Because during that shutdown and startup process, AppArmor won't be protecting anything. So at that point, the machine would be vulnerable and anybody could get into the actual machine or any of the services, or if they've compromised a service, to suddenly start changing files. So fortunately, there is a mechanism called AppArmor Parser. And what that program does is allows us to dynamically change the profile for a process. So using sudo AppArmor Parser and then telling it to read in a specific configuration file, we can dynamically change the profiles and therefore not compromise the profile of protection on any other processes which are running at the same time. So rather than actually shutting the AppArmor service and bringing it back up, what we actually do is we just refresh the profile with this command. We could simply restart the whole machine, but that's not the best way to do things if we can avoid it. Because during that reboot process, the service we're trying to put on the network is basically being shut down. And we don't want to shut down services. We want to keep them running as much as we can. So we would flush the actual profile rather than restart the machine if we can. So once that's up and running, we now have logging in place and we can go back. Now, something you should consider with logging is when and where you should be doing it. You should be doing it when you're actually trying to analyze the profile of use of the infrastructure. But when you're logging it, what you should do is you should log it on all of the DNS servers, even the primary. Because by logging everything that goes on with respect to queries, you can see where the queries are being run, you can consolidate them all, and then you can actually get a better view or an overall profile of the service. And the reason for putting it on the primary server is if you get the security settings incorrect and people are running queries off it, this will show you. So you would go back and reconfigure it. So you log it on everything, but you only do it for short periods of time because the log files will get large. And then obviously, if you filled a file system, the service may stop running. So you would switch it on, capture the data, switch it off, collate that data together, analyze it, and then go back and make the changes to the configurations to get the maximum performance from your DNS. So what have we looked at in this session? Well, in this session, we've looked at a few things. One of them being the DNS secondary servers and how we install them and set them up. We've also looked at how that impacts on the network, how we can log transactions to then go back in and start tweaking the parameters to get the performance that we want. And using the logging mechanisms, we can do a lot more than just look at what the DNS service is doing. We can use it to analyze user activity to start setting up some of the security aspects on the network. So you put them all together and we've now got a fully functional domain name service. What we're going to do now is we're going to build all of this in the workshop. So as you can imagine, we've been working with one server up to now. Now we're going to start moving this and having multiple servers. So you've got at least 2 more servers to build before we get into the workshop. So before you get to the workshop and start going through it, I suggest you have 3 server machines running. You've already got the primary machine that you initially started with. Get yourself another 2 headless machines so we're ready to do the workshop, and I'll see you there.